copper. Greetings! Well, this time I have the Legend Hobby Seagull Models Cessna 188 Agwagon. Yes, if you want a wagon, it might as well be an Agwagon. Agwagons, of course, are known for their crop dusting ability and also glider towing and various types of agricultural work in the air. And they're commonly seen all around the United States and other parts. And they've been around for a long time. And this is a 97-inch all balsa ply constructed model airplane. It's designed around 35cc gas engines or electric equivalent. And this thing has some really neat scale features to it. And it's a really nice size, very colorful as you see. And we are going to put it together and see how she goes. Let's not waste any more time and open her up and see how it works. This fiberglass cowl is quite snazzy, with painted on colors and striping along with a nice glossy gel coat. Tail is a combination of sheeted and open structure balsa construction with heat shrink covering. Hinges are CA type. Same for the wings, although it's obvious the construction is relatively complicated with pronounced wing struts in the middle. Considerable time must have been spent giving it a nice set of color details. I know that there are pull strings for the servo wires. Fuselage has the most intricate color scheme. They really went all out in this model. Firewall has thick fiberglass plate reinforcement. Unfortunately, in inspecting the fuse, I accidentally pulled apart the cockpit frame. But it should be an easy fix with some epoxy. I can't have anything nice. Top hatch is huge, allowing easy access to the interior. Inside is Seagull's typical intricate and well-engineered wood structure. The included pilot is, well, mostly human-shaped. Must have been sculpted by Jerry Anderson.
Anything can happen in the next half hour.
And despite being hollow, it is surprisingly heavy. Manual has lots of clear pictures in logical steps. You also get a decal sheet of peel and stick livery. Okay, so the first thing I needed to do was fix my ham-fisted handling of the canopy frame with some epoxy. The tab and slot construction helped realign everything back up easily. Flap hinges are assembled from two pieces that snap together. Screw holes are already marked, so there's no question of where to mount them. No alignment holes on the flap side, but you don't need them either. However, I wasn't thrilled how the pivot would spread apart after rotating just a few times. I may not fly it that way. Like all tail surfaces, ailerons use cloth hinges that are glued in with thin CA. Fiberglass control horns are prepped for gluing by some light sanding on their base. And then epoxied into the control surface. And the control rods. The flap hinges continued to trigger me, so I had an idea. I cut off the nubs, then drilled out a pivot hole. In my RTL fastener screw set, I pulled out some 256 screws and lock nuts. The screws fit nicely in the existing hinge line holes. Much better. Now I can sleep at night. The aluminum spray bar will take a few steps to assemble and install. There are a bunch of neat nozzles, which we'll get to later. While I was at it, I test fit the wing strut. Then I moved on to the fuselage, where I get on with installing the servos. And then the undercarriage. Some thread locks so I can sleep the next night. Wing struts have some fancy fairings that need to be installed. Might as well install the wheels while I'm at it. Alright, motivation for this baby will be provided by a Stinger 35cc rear exhaust engine. Me and Stinger engines have been quite well acquainted over the last few years. Okay, so I'm at the part where the manual says, install the engine now, dummy. So the engine I will be installing is the RCGF Stinger 35cc RE for rear exhaust. So yes, I figured the rear exhaust would fit really well in this, considering some things I'm going to be doing with it. And here's the muffler that will fit in the back. We'll probably install it inverted style like this and pop it in. Now, this is probably, I don't know, fourth or fifth time I've installed a Stinger engine in something, and I found them to be really good engines. They're really nice, good power, very reliable, so I have no qualms about slapping one of these into the Agwagon, and we will go from there. So right now I'm going to have to mount it to the firewall, probably change one of the arms like I usually do to a little longer arm, and it's got a nice little choke. I will also see if I can install a servo-controlled remote choke, because that's how I roll. Yeah. The Cessna kit includes this handy drilling template for various engine and motors, with the DLE markings looking to be the right match for the Stinger. The template simply slides over the motor box for easy alignment. For the blind nuts, I like to use a short screw to pull them tight first, before mounting the engine. Hey, it's starting to look like an airplane. Test fitting the cowl showed the engine was set at the proper distance forward. I needed to take the engine off so I could drill out the opening for the control rods. You will need to move the covering from the center of the horizontal stab. I marked the center to help with alignment. I've gotten used to using my battery-powered soldering iron to remove the covering. For a good bond, I use 30-minute epoxy. And some weights while the glue cures. Then it's on to adding the vertical stabilizer. Gluing the CA hinges. Throw in the control rods. Mount the tail wheel. And assemble the pull cables for the tail wheel. I will be adding an additional tank for the smoke fluid, which will have to be assembled. Same for the included fuel tank. To keep the tanks from moving around, I glued various bits of balsa to the tank tray to act as brackets. The two tanks just fit in the fuselage slot. Now for the smoke system, I'll be using a Sullivan remote-controlled smoke pump. It's a pretty solid unit that is easy to hook up and has a variable speed pump control. I found that there's just enough room in front of the tank tray for the ignition module. While the smoke pump itself is mounted to the firewall. Okay, so let's take a look at the plumbing I'll be using. I bought some high temperature silicone tubing and some brass L joints, as I thought the included fake plumbing would likely not be usable. Okay, now that I got the smoke pump installed, it's really kind of up to me to figure out how I'm going to pump the exhaust into the spray bars. Now the kit comes with some, well, sort of fake tubing. It's some of it's kind of hollow, but some of it's not. It's really just meant to look like it's a plumbing system. But I tried to see if I could use it, and I really couldn't think of a way I could use it. So I actually had to go out and get some other stuff, and it involved some copper plumbing supplies. The silicone tubing was sized for a pretty nice fit over the aluminum spray bar. Same for the brass fitting. The plan is to use the tubing and brass fitting to divert the exhaust back to the wings. It's kind of a long run, and I'll need to be careful not to have any kind of kinks in the bends. I'll also need to trim the bottom of the cowl to clear space for the exhaust ports. To do the cylinder head cutout, I use a template made from a manila folder. I use the same technique to locate the screw mounting holes. There are two large LEDs that are installed in the front of the cowl. I happen to notice there looks to be optional cooling slots for the electric version. Anyways, the spray nozzles are an interesting mix of air hose, push connectors, and laser cut wood parts. But importantly, the fitting part is hollow. These nozzles fit into the trailing edge openings. I also drill out the spray openings a bit. I use JB Weld to glue the nozzles in place. Next was to install the smoke spray bars into the muffler. Measure twice, cut once. I learned my lesson with the L19, and this time I use a second nut inside the muffler. It was then I realized the smoke pump was in the way of the engine mixture control screws, so I moved it to the other side. Why didn't somebody tell me I did that? Before I got too involved in the smoke plumbing, I decided to start up the engine for the first time to make sure it ran okay. Purred like a kitten. Okay, now I felt confident to plumb up and connect the smoke system. I'll use a separate channel on the transmitter to activate it. I also noticed you have to be really careful with the rudder throw so it doesn't interfere with the elevator. Okay, so test run up 2 will exercise the smoke system. Plumbing is a bit of a mess, but it's only a test. It seemed to work well enough, but I'll need to secure the exhaust tubing better with some hose clamps. Going back to the spray bars, I decided to close the open ends with some balsa plugs. Then finish off the cockpit and canopy details. Smoke and refueling fittings are installed. And it's time to connect up the remaining parts of the exhaust tubing. This is what we technical types call an integrated test. Time to see how it all works in the final configuration. Well, it mostly works, but I'm going to hunt down a couple of leaks in the system. So it's time to put the finishing touches on everything and start making a battery mounting plate for the third battery. After checking the balance using a handy balance cradle called a CGR stand, This is actually a dual-purpose plane cradle and balancer for large models. I'll need to add about a pound of weight in the nose with this dive weight, plus another 8 ounces with smaller weights. If you noticed earlier, the exhaust was blowing by the spray bar fitting, so I tie wrapped them on more tightly. Fiberglass wing strut fairings also need to be added. Oh, I forgot to mention the LEDs will need a current limiting resistor added to the power leads. Around 300 ohms should be good. Decals are added as a finishing touch. Oddly, the numbers didn't fit well due to their length, so I removed one of the digits. It'll be our little secret. Okay, so one last thing. When I went out to do another engine run-up test, it didn't sound good at all. And when I put a tachometer on it, instead of reading the normal 7,000 RPM or so, it was just over 5,000. And I was thinking, what the heck happened? Well, it turns out that plugging all the exhaust leaks severely restricted exhaust pressure. So I had to drill out the spray nozzles as large as I dared and even open up the end caps a bit. Now, once I did that, the RPMs were pretty much back to normal. So, okay, so next time we'll see you, we'll take her up to the skies and see how well she flies and sprays. Thanks for watching. Hi, thanks for watching. Please take a look at the video description below for special HobbyView sales and discounts. Your purchases help support this channel. Happy modeling!